processor fundamentals. We can even call it the computer architecture, but we want to know more about the computer architecture in general. Yeah. So what we're going to be having here is we're going to appreciate von Neumann, of course. That's the first person that's going to be coming in our minds whenever we start to talk about processor fundamentals. I'm talking about John von Neumann, innit? So the first thing that you need to appreciate is that von Neumann brought in the stored program concept, or he allowed computers, or his architecture was based on the part or on the concept that the computer is supposed to be using a stored program concept. What this basically means is that a computer is supposed to be having both the data in the program, instructions, stored temporarily in the main memory. Then, after they are stored in the main memory, we can then carry on the fetch, decode, and execute cycle after that. So for the meantime, just know that the stored program concept, you have data and program instructions both stored temporarily in the main memory for them to be executed. Okay, if it's not making any sense as of now, don't worry, you will get this by the end of this session. So check this out. Von Neumann now, he had a computer architecture that was designed based on the 4 basic functions of a computer. The 4 basic functions of a computer, we have input. So we had the input part of a computer. Then from input, we then give this information to the processor. That is the part of processing. From there, we give this information to the output part, where we are going to be displaying this information, of which the process works hand in hand with the storage. Yeah, with the storage. So we're going to be having information that has to be stored first, and this works hand in hand, which means this is two-directional. So von Neumann proposed that a computer is supposed to be coming through with the input part, the process part, the storage part, and the output part. So when he was now proposing the part, okay, the input part is going to be helping us to feed information into the computer, right? After feeding the information into the computer, we can then take it for storage, right, in different storage devices, like in the hard drive, in the RAM, in the solid state drive. Then when we want to display it, we then put it through the output devices. That's basically what the architecture was basically all made up of. The process part now, we had the processor for this reason, was responsible for changing the data into information, or for any processing that needs to be done to the data. It was supposed to be dealt with in the processor. So with that reason now, that's when the stored program concept comes in. When we want to run a program, we're supposed to be having the data and its program instructions being stored in the storage. Then we then fetch them from the storage to put them in the processor for decoding and execution. That's basically what we have. So let everything be stored first. Let the data in the programs be in the storage. That is the main memory. Then let it then be stored. Let it then be fetched into the processor for any for the decoding and execution. I hope that makes sense. So we store them in the main memory. Then we fetch them from the main memory into the CPU for the purposes of decoding and executing. When we are decoding, we're just trying to get the meaning or what we are supposed to be doing with the data. The processor will be just trying to get to understand what it is supposed to do on the data that it has just fetched from the main memory. That's basically what decoding is all about. It's trying to understand the meaning behind the instructions. When we now talk about the part on execution, this is when the processor now starts to execute or starts to do or starts the running process of the program, because it now has understood what it is supposed to do on the data that it has fetched when it was using the instructions that are in the program. I hope that makes sense. So with that now, let me say, let's now get in detail to talk more now about the part on the processor fundamentals. So I'll clear this now so that we can actually have this in its more explained version of it. So basically what we have is we're going to be having the input, of course, different input devices which are used to feed into the computer. We're talking about the mouse, the keyboard, and stuff like that. Those are going to be coming through to be our input devices. So they're going to be giving these to the processor now. So for this reason, I'm going to be having the processor coming through a little bit big like this. That's going to be coming through as our processor. Then from there now we can go ahead and actually give this information to the output devices. Then we have the information now again stored in the main memory. Right. Some of the things that we are supposed to be appreciating with the von Neumann architecture are this. We have we already mentioned about the stored program concept, where data and programs are supposed to be stored temporarily in the main memory. So this is going to be acting as our main memory. Main memory. And this is going to be acting as our CPU, right? So this is going to be coming through to be our CPU, the central processing unit. So we are saying programs that are stored in the main memory, they are supposed to be fetched from there now into the what? Into the CPU. Once they are in the CPU now, that's when they are supposed to be decoded from there, right? So we're talking about this is the fetch part. So the fetch is done by, when you're taking data from the main memory to the CPU, we're going to be using the data bus. The data bus is nothing but just one of the buses. We have the system bus, which consists of 3 buses, right? The system bus is the main media for data transportation in the CPU. I'm just using the word data transportation because it's data, but some of the information might actually be addresses, not just data. But for the meantime, we're saying the data bus is one of the elements of the system bus that carries data to and from the CPU. One thing that you're already seeing there is that the data bus is bidirectional, right? It's bidirectional, which means it goes both ways. It carries data to the CPU and back from the CPU back into the main memory, right? So check this part now. When you're doing the fetch part, the first thing that's going to be happening is this. The CPU, before we even start talking about the fetch part, the CPU is made up of 3 basic components. 3 major components, rather. There are many elements of the CPU, but rather I'm going to be talking about starting with 3 right now. 1, the CPU is made up of the control unit. We'll mention its purpose just in a second. The control unit, then it is also made up of the arithmetic and logic unit. We call it the ALU, arithmetic and logic unit. And the last part that I want to mention are the registers. So we'll talk about these in detail as we'll be going. Of course, again, you'll see that there are also buses in here. There's also the system clock, right? We'll talk about those in a second, but rather let's have these as the 3 main components of the CPU, right? So what's going to be having now on the fetch part, the first thing that's going to be happening as far as fetch is concerned is that we're going to be having a register that is called the program counter. The program counter, or the PC. So PC is standing in for the program counter. So this register, it stores the address of the next instruction that needs to be executed. It stores the address of the next instruction. It doesn't store the next instruction, it stores the address of that next instruction that needs to be executed, right? So we are saying that it stores the address of the next instruction. Address of the next instruction, right, that needs to be executed. So let's just have, for example, that we have this as our main memory, and we have the instructions, instruction A here, instruction B, instruction C, and instruction D, right? Suppose. So this is sitting on address number 1, address number 2, address number 3, address number 4. So suppose that we are already executing instruction number 1, which is A, right? A is already being executed, which means that in the PC, there is going to be 2 to indicate the address of the next instruction that needs to be executed. So take note that the PC stores the address, not the instruction itself, but the address of the next instruction that needs to be executed. I hope you will not confuse yourself on that part. So what you're going to be having now from here, the first step that's going to be happening as far as fetch is concerned, is that the address that is in the PC is going to be copied to the memory address register, right? So we can put this in register notation like this. We are saying that the first thing that's going to be happening as far as fetch is concerned, we're going to be having the address that is stored in the PC. So if I say PC like this and I put square brackets like this, I'm saying the contents of the PC are going to be given to the MAR, memory address register. So the memory address register is going to be receiving the address that is stored in the PC. And you can guess which bus is going to be used to do that. Yes, if you guessed address bus, you were correct, because we are carrying addresses here. It's going to be the address bus. It's going to be used to carry an address from the PC to the MAR. And by this, you can see that it is only going one directional, which means it's not bidirectional, but it's unidirectional. It only goes one direction, right? Carrying addresses. Okay, that's the first step. We're going to be having the PC, the contents of the PC being passed to the MAR. The next thing that's going to be happening now, there is a connection now between the MAR and the memory, the main memory, whereby we are saying now the contents that are stored in the address contained in the MAR, the contents, right? The contents of the address. We want the contents, but the contents of the address that is stored in the MAR. Stored in the MAR. So in this session, we're talking about what? We're talking about B. Because B are the contents that are stored in the address in the MAR. Because in the MAR, we're going to be having 2. So in 2, there is B, because we want the contents. So these contents now are the ones that are going to be taken now into the CPU. Check this part. We're going to be having this information moving now by the data bus into the CPU. That's going to be coming through now to be stored in the MDR. MDR, the memory data register. So what this does, basically, it stores or it receives instructions and data from the main memory. So we are saying that step number 2, it's involving the contents of the address that is stored in the MAR. That's why we have to put 2 brackets there, because we want the contents of the contents. I hope that makes sense. So that's the okay, let me just remove that. I'm putting that in the MDR, the memory data register. So the second step is involving the memory data register receiving information that is stored in the contents of the MAR. That's basically what's happening there. So what is stored in 2 is the one that is what we need to go now into the MDR. That's going to be step number 2. Step number 3 now is going to be involving us, the MDR, giving this information now to the current instruction register. I love this part now for some reason. Let me just explain why. Information coming through into the memory data register. Oh, I didn't mention that the memory data register can also be called the MBR, the memory buffer register. These are substitutable names. So the MDR or the MBR is just a buffer register. It just stores information that needs to be processed. Check this part. It also stores instructions and data that needs to be written back to the main memory. So the function of the MDR is going to be coming through to be to store instructions and data from the main memory, or the ones that are going to be written to the main memory. I hope you understood that part. So we're now talking about the part of the CIR that the MDR is just a buffer. It needs to give the instruction that it contains into the CIR for them to be decoded. Together, when check note, we are still doing the fetch here. So that's what's going to be happening on the 3rd step now. Okay, let me just change my highlighter real quick. Let me put something like green. Number 3, we are saying that the contents of the MDR are going to be given to this dude, the CIR, the current instruction register. Current instruction register. So this dude will receive now the instructions that are just passed on the data that is from the MDR. Then that's when we then have one of the units coming into play now, which is called the control unit. The control unit will then help in the decoding part now. Right? It tries to get the meaning of the data that is in the CIR. I didn't mention this part. I love this process because it's actually a dual process. As soon as we have data moving from the MDR into the CIR, the value of the PC is also incremented. Once we have information moving from the MDR to the CAR, the PC value is going to be incremented, which means the PC, what was contained in the PC, is going to be added by 1 and stored back again in the PC. I hope that makes sense. So the contents of the PC are going to be incremented by 1 and stored back in the PC, which means once we now have B here, it means that the address of the next instruction is no longer 2, but it's now 3. So the value of 2 is going to be incremented by 1 to indicate that we now have 3 in here. So this happens simultaneously. As soon as the instructions that are in the MD, as the data in the instructions in the MDR are going to be passed in the CAR, we're going to be having now the value of the PC being incremented by 1 to indicate or to now point on the data on the next instruction that needs to be executed. So that's what is happening on this step. C with the fetch. So the second step now, we just finished the part on fetching. The second step that's going to be involved now in the fetch, decode, execute cycle is the decode part. The decoding part is going to be having now the data contained in the CIR and the CU, the control unit. The control unit will be then doing the part of trying to decode or trying to understand what the instructions stored in the what the instructions that are stored in the CIR are actually what are actually meaning. So once that is done now, once we now have the instructions, or once the CPU has understood what needs to be done, if there is any need for any calculations, right? That's when we're gonna be getting in the execution stage now. On the execution stage, you're gonna be calling now the other unit, which is called the arithmetic and logic unit. This unit deals with calculations. So any logical calculation that needs to, any logical operation that needs to be done on the data is going to be passed on. We're going to be calling in the help of the arithmetic and logic unit. And this now works hand in hand with the register that is called the accumulator. So the accumulator basically, it stores the interim values or the interim results during calculations. Suppose I say 2 plus 2, I get the answer 4. If I go ahead and say plus 6, I'm going to be getting the answer 10. Take note that I didn't say 4 plus 10, I just said plus 10, which means the intermediate result, which is 4, was stored in the accumulator. I hope you get that part. Because this dude is responsible for storing interim results during calculation. Interim results during calculations. Some sources will tell you that the accumulator is inside the ALU. Some they will tell you that they work hand in hand. Either way, just know that the ALU and the accumulator are inseparable. These guys, they're going to be working hand in hand. The part that they are, one is inside and the other one is outside, we don't really get to worry about that. Just know exactly what they do and what they specialize in doing. That's basically what we have as far as the accumulator and the ALU are concerned. So we had an appreciation on of what the control unit does. It's responsible for coordinating everything that's happening in the CPU and also for the decoding part. The ALU is responsible for doing the part of carrying out any arithmetic operations or any logical operations within the CPU, and it always works hand in hand with the accumulator. Then the registers that we just mentioned here, we mentioned the special purpose registers. We have the program counter, which stores the address of the next instruction to be executed. The MAR, which receives again the address of the next instruction to be executed from the PC. Then we have also the MDR, which receives instructions and data from the main memory, or it stores data that is about to be written back to the main memory, which means it's a dual function. Then we spoke about the CIR, which holds the currently being executed or currently being decoded programs, right? All the programs that are currently being decoded or currently being executed, they're going to be stored in the CIR. Then we mentioned again the accumulator, which stores the interim results during calculations. And it always works hand in hand with the ALU, which is the arithmetic and logic unit. So if there is any other peripheral device or any device that needs to be actually used other than the CPU, we have now what is called the control unit, which is also a bus that connects now to all other parts of the computer from the control unit. So the control bus basically it carries the control signals to different parts of the computer. It carries control signals to different parts of the computer. So if you're asked about the system bus, you need to mention about its divisions. We have one, the data bus, which is bidirectional, carrying data from and to the CPU. You get the point? The data bus, which is bidirectional, carrying only data and instructions. Then we also have the part of the address bus, which is unidirectional now. The address bus, it only goes one way. It carries only addresses, right? This is also the address bus, by the way, because it's carrying addresses from here to here. So this is unidirectional. Unidirectional like this. Then the last thing that we talked about was the control bus, which carries the control signals. The control bus, which carries the control signals from the control units to different parts of the computer, right? And this can be bidirectional or unidirectional depending on the connection, on which device it's connected to. So it's bi or unidirectional. That's basically what we have. So that's what we have as far as the fetch, decode, execute cycle is concerned, and the computer architecture in general. I don't know if there are any questions. If there are any questions, please touch base with me so that we can address all the questions that you have. The next thing that you want to be talking about is the how interrupts are handled and what interrupts are altogether. So always know that the fetch includes the PC, right? The PC giving value to the MAR. Second, the contents of the data, the contents of the address stored in the MAR are then going to be given to the MDR. Third step involves the MDR, the contents of the MDR being given to the CAR for decoding and execution. Then at the same time, the value contained in the PC is incremented by 1. Then the next thing that's going to be happening is now the decoding part. Decoding, we are trying to understand, we're trying to understand what the instruction actually means. Then once we have that information, we go on the execution part, where we get to run the program or do what the program wants us to do. So this is where, again, calculations are going to be carried out. And even any logical operations. Logical operations are going to be carried out on this stage. So that's basically what we have as far as the processor fundamentals are concerned. Feel free to touch base with me if there are any questions, and make sure you know the functions of each and every bus that is in here. Okay.